second slide, it is inter-process communication. As I have said before, the inter-process communication is used for, at a time, more number of processes may be executing concurrently in the system. A process is called independent if it cannot be affected by any other processes. A process is called cooperating if it is affected or can affect any other processes. It means there are two types of process. One is independent and the other one is correlated process. The independent process cannot be affected by any other process and it cannot affect any other processes. So where IPC is not used in this section, that is the independent process, we use IPC, and IPC existence comes into spotlight only in correlative process. In this correlative process, we use two types, that is shared memory and message passing. Okay, let me go to the next slide. We'll be discussing about the shared memory region. In a shared memory method, a region of many shared by process is created. The process can exchange information by reading and writing data to the shared memory. A process creates the shared memory segment. Any process wants to communicate with the process creating the shared memory must attach the shared memory to its address space. Generally, the operating system prevents one process from accessing other process memory. This restriction is omitted in shared memory method. Okay, let me show you the diagram or representative of shared memory, then it will be able, or it will be very easy for us to explain it. See, this is diagrammatic form of shared memory region. There are two processes, process A and process B. Process A wants to communicate with process B, but in the shared memory region, process A communicates with process B with a shared allocated memory region. It means A passes the message to the shared memory and B receives the message from shared memory. At the bottom you can see there is a kernel mode. This kernel mode comes into existence until there is a shared memory region established between process A and process B. Then only the kernel mode comes into interference. After the establishment of shared memory region, the kernel mode no more no more interference in the process. As I have said before, process A communicates to shared memory region and shared memory passes the memory to the process B. This is how the shared memory region works. And let me tell you about the second thing, that is message passing. You can see in the slide, message passing, the process can be communicated by exchanging short messages. In easy way, it is like the modern technology WhatsApp. If I want to communicate with some K person, I send the message and the K person receives the message and sends it back to me. That's what message passing, and that's how it works. In message passing, as I have said before, send and receive between me and some K person, and communication line are used for exchanging messages. Several methods are used for implementing the line send receive operations. Naming in the mechanism direct communication or indirect communication is used between the communication process. Let me tell you about the direct communication. The direct communication is, let me take the same example as I have said before, that is me and some person K. I am sending the message to person K. The person K is receiving the messages. But in this direct memory, I need to send the message. I need to know the ID of the person K. Then only I can send the message. It is like I need to enter the ID of the person K and then the message that what I should have sent. Okay. Then only the message will be received by the person K. In the same way, person K needs to have my ID, then only he'll be receiving the message and he'll be able to read the message. This is called direct communication. In indirect communication, there is a feasibility that sender need not receive any ID. He can just send the message. And in the same way, receiver also need not to enter any ID. He will enter the message. I mean, he will receive the message. But in this, the first message will be sent through ID and the remaining messages, no need of entering any ID or giving the details of the person K. So this is how indirect communication works. Let me show you the diagram. This see, there is process A, process B and kernel mode. As the kernel mode is common in both shared memory and message passing. The process A communicates with process B through kernel mode. It means in this kernel mode comes into interference until the process or the message sharing is done. Till the end, kernel mode is interfered. Process A sends the message, and through kernel, process B receives the message. In present technology, when compared between these shared memory and message passing, shared memory is a bit faster, but when you're working between the systems, it is most recommended to use message passing. Why? Because in message passing, yes, it is a slight delay in message passing, but there is no other disadvantage. But when it comes to the shared memory region, there is a major disadvantage, that is cache coherency issues. Where the data is storing, their issue is raised called cache coherency issue. This issue is raised due to the data is migrating through several cached regions. So that is the reason why this cache coherency issue is rising. Other than those, the shared memory is region a bit faster when compared to the message passing. And you can ask me when to use this. When you are working within the system, use shared memory region. But when you are working between the systems, it is preferable. It is not preferable, it is the only choice for better results. We use message passing. So this is how IPC works. And thank you. I hope all of you get it right. And myself, Amar, thank you.